Greetings, Dennis Daniels here. I have come up with a binary classification. In this case, what we're doing is calculating the cost and the value of avoiding potholes in the road. And I've established a score here. This is randomly generated numbers. These are all randomly generated. And the score is going to be used as my threshold. Now, for example, if these are the false positive and the true positive ratios or rate, and this has been generated by some other algorithm, and I need to set a threshold for when, for example, I'm a computer, I'm a robot driving in the car, and I want to determine whether or not my current score is going to prevent me from damaging the car. And in this case, I've got 18 or so scores here, and I have my false positives, my true positives, and then I have my confirmed. Now in this case, you'll see 64, score of 64, I have a true, score of 65, I have a false, 65 true, 78 false, 88 false, and 91 true. So I'm not quite sure what to do. So I have to set a threshold. Now, we're going to use a confusion matrix, and rightfully called a confusion matrix, because if you don't know what it is, it can be confusing. But just to give a demonstration, I'm going to set my confusion threshold at 65. That means anything over 65, I'm going to react, whether I stop the car or turn the car or something. That's my threshold. So if my threshold is 65, it's right here. And that means that I have, in terms of true positives, I have 2 true positives over 65. 1, 2 true positives. I have 3 false positives. And then what you're going to quickly point out is, well, if I set it 65, then I'm going to have I'll have a true positive that's confirmed, which is going to be bad. False negatives are bad because it tells me I didn't do my numbers right, depending, of course, on the cost, and we'll get to that in a moment. So there's my numbers. I've got 3 false positives, 1, 2, 3, 2 positives, 1, 2, 1 false negative, and the rest are true negatives, meaning they are confirmed as not, and they're confirmed as false. Now, our threshold at 60 produces a different result. Now, 60 is in between 54 and 61, so if our threshold is set at 60, then I have 1, 2, 3 true positives. I have no false negatives because there are no trues here. So I have 0 false negatives, which is good. But then you'll notice I have 4 false positives at 60. 1, 2, 3, 4 false positives. This is bad, but it's not that bad until we understand the cost. Now, these are arbitrary numbers, and of course you're going to set your own threshold costs. But in this case, I've set my true positive to a value of 500, my false negative to a value of 3,000, my false positive to a value of 500, and my true negative actually does have a value as well, but I didn't include that here, and you can add your own. Now, when I do the numbers here, you'll see that if I set my threshold cost at 65, because my false negative is so expensive, I break the car, I damage the suspension of the vehicle, I fall into the pothole entirely, whatever. The false negative is more expensive, generally. And it's one of the reasons why we want to avoid it, especially if you are doing medical statistical analysis on treatments. Your false negatives are very costly. This is where you involve lives. So let's put the cost here. So the cost, if we multiply them across 65, 2 times 500, 1 times 3,000, 2 times 500, that gives us a value of 5,000. That's the cost, okay? Because every decision has a cost. Now, if I set the threshold to 60, then I have more true positives, which are annoying, but I have no false negatives, which is reassuring. I also have 4 false positives, which means I might be doing extra work, but the extra work, when it's calculated against the true cost of this threshold, is 1,500 units or $1,500 less than a threshold of 65. So almost any rational individual would choose a threshold of 60 in terms of making their decisions based on their incoming data and based on this particular confusion matrix. Now, I highly recommend you play with these so that you understand them, because they can be quite informative in terms of how you can approach other statistical problems. Thank you for your time, and happy computing.